Hello guys, I hope you are all doing well. In this video, we are going to talk about unions in C programming language. So let's begin. Before diving into the union, one thing that you should remember that structure and union are completely the same thing, except in structure every element has its own space or own memory, but in unions every element of a variable will have the same memory. How? Let's say there was structure element, okay, before let's say there is structure element, okay, and the variable name is a. Now in this case integer a will have the different memory location of 2 byte, let's say for 16-bit compiler, right, and character C will have completely different memory. But when I am using union, then there will be a 2 byte memory for A and same memory bytes will be for character C. Okay, this is only the difference, that union elements will enjoy the same memory locations, right? So let's see slowly how it is used. Now first of all we have to see who has the highest number of bytes. For example, for 16-bit of compiler, this will be integer will be of 2 byte and character will be of 1 byte, right? So here integer have the highest space of memory, which is of 2 byte. Okay, so the maximum memory which will be given to our union variable will be of 2 byte. For example, if I write here printf %d and then size of a, then it will give me output as 2 byte, right? If this was a structure, then the output would have been 3 byte, 2 byte for integer and 1 byte for C or character, right? But here we are using the union. So the maximum size of data type used by our variable a is of data type integer, which is of 2 byte. Okay, so right now our variable a is having the total memory of 2 bytes. So this will give output as 2. Note that I am using here 16-bit of compiler. For 32-bit and 64-bit the output would have been 4 byte, right? So there is 1 byte and another is 1 byte and total is 2 byte, right? This is 2 byte, right? And every byte will have 8 bits. Now the question arises how we use the union variables. Before going further, I will change this variable to I, okay, just to make it a little different. Okay, now let's say I'll write here a dot I equals to 4. Now what will happen? A dot I, basically this entire memory is of 2 byte or for the I variable. Okay, to access these 2 bytes I'll write a dot I, and to access this particular character I'll write a dot C, okay, which will be of 1 byte. This is of 1 byte, right? So I am writing here a dot I equals to 4 and binary equivalent of 4 will be 0, 0 and 1, right? Now if I am writing printf %d and then I write a dot I, the decimal equivalent of these 2 bytes will be 4. Okay, so this will give me output as 4. But let's say I'll write %d and then I'll write a dot C. Okay, in this case if you notice here that this memory location or the content present in this byte has also been changed. So now here also our output will be 4. So now you can see that changing the one element will also affect the other element. Similarly, let's say instead of C I write here make an array and I write here C2. Okay, so now what will happen? This will be for AC0 and this will be for AC1, right? And let's say here I am writing a dot I equals to 257. Okay, now the binary equivalent of 257 will be 1 0 0 0 0 0 0 and 1. Okay, and all this will be 0, right? So now if I do printf %d a dot I, it will give me output as 257. Okay, when we are talking about the output, is it taking entire 2 bytes, right? Now let's say I'll write here a dot C 0. Now what will be the output of this? A dot C0, a dot C0. Now what is the binary equivalent of this byte? It is 1. So it will give me output as 1, right? Similarly, if I write here a dot C then 1, now what is the binary equivalent of this byte? Okay, this is 0 0 0, everything is 0, so binary equivalent of this byte is also 1, so this will also give me output as 1. Now let's say instead of 257 there is 258. In this case the binary equivalent of 258 will be here 0 0 0 and then at the end 1 0. Now if I find a.c0, it will give me a decimal equivalent of this byte which will be 2. So here it will give me output as 2, right? And here the binary equivalent of this will stay the 1. So a.c1 will give still me the output as 1. So this is how we use the union. Now let's say that I'll write here a.c0 equals to, let's say, 5, right? Now what it means that a.c0, the byte of a.c0 will be equal to the 5. Now the binary equivalent of 5 will be 1 0 and 1. Okay, now if you see here that changing the a.c0 will also changing our a.i, okay, value of a.i. Okay, so now if I do here printf of %d a.i, it will give me the decimal equivalent of this entire byte. So decimal, it will give me output for the decimal equivalent for these binary digits, which will be equal to 261. So now if I do here printf of %d a.i, it will give me output as 261. Okay, so changing the data of the one element will also affect the data present for the other element, right? And now a.c0 here will give me output as 5, right? Now you can predict what is happening when we are using the unions. Okay, now let's say instead of using char c2, I'll write here char c3. Okay, so now 3 byte of memory is required for our array variable c. Now note here that this much memory is not present by our integer variable, so extra block of memory will now be used. Okay, and the size of the new block of memory will be equal to the highest data type that we are using. So this will also be now of 2 byte, right? And this 1 byte will be used by a.c2. Okay, so remember that if let's say there was 5, right? So this will be for a.c3, sorry. Okay, still another variable or another byte is required. So another entire piece of 2 byte will be taken instead of 1. Why? Because the data type of the maximum size is always taken. Okay, so this will be taken for a.c4, right? And this will be for 2 byte, right? So let's say I'm writing here C3, okay, this is not present, and in this case if we write printf size of a, then it will give me output as 2 byte for this and 2 byte for this. Okay, so this will give me output as 4, right? Note that these 2 byte of memory and these 2 byte of memory is now used by our a variable. Okay, so size of the a variable is 4, right? One more thing, that let's say instead of writing here integer, I'll write here long. Okay, and then the long will be of 4 byte. Now for 4 byte, let's me make another byte, and let's say these are 2 byte. So this 1 byte can now be used by a.c2. Okay, in this case this will not be required, and this entirely will be of 4 byte, right? So I hope you are getting what I am trying to say, that if the data is able to embed here, then it's fine, it will be embedded. But if it is not, then extra piece of block of memory will be taken, and the size of that memory will be equal to the highest data type used by the element. Okay, for example, again if I write here, let's say 5. Okay, so a.c2 could be used here, a.c3 could be used here, but for a.c4, this 4 byte of memory is not enough, so additional block of memory will be used again. Now what will be the size of the additional block of memory? It will be a 4 byte. Why 4 byte? Because the size of the highest data type is a 4 byte. Okay, so this again of 4 byte of extra memory will be used now, and this byte will be used for the a.c4, right? So this is how the size of our union variable increasing. In this case our output will be of 8 byte, right? So remember this. Now one question that people ask many times is that why we even require to use unions in C. To understand the importance, you have to realize that unions are used when you want to access a particular memory by different variables, right? By different variable, let's say A and B. For example, let's say that you want that age of the man, let's say for the man you have to store age, and for a woman you have to store number of years that she had work, right? Number of years of her work, right? Now you will write here int, let's say age, right? Or let's say m underscore age, and you can also write here int n years, right? Now in your programming, what will happen that whenever you will encountering the female gender, then you can write if, let's say, the gender of that particular is female. For female you can store the values in s dot n years, right? And when the gender is male, then you can store the values in s dot m age. So what is happening here? Instead of using 2 bytes different for this and 2 bytes different of this, we are using a 2 bytes for both of the data, right? So somehow we are able to save our 2 bytes of memory. Now this is a very basic example, and in the real world there are various other cases when we use union, right? Most of the people don't prefer to use unions because it is quite complex and it simultaneously changes the other data also. Some people use it and some don't, right? One last thing is that whatever I told you about the unions in this video is according to the Little Indian CPUs, right, or processors. It may happen that when you are using the processor which follow the big endians rules, then the output may vary because they use the different method of storing the bytes, right? I had talked about unions for the Little Indian processor since they are more common in use, right? So that's all for today guys. I hope you like the video. If you have any doubt, please comment it down. Thanks for watching, and I have to see you in the next video.